Hello, I'm Ryan Oswald.
And I'm Eric Vickard.
This is our IoT project, MapMyAir.
Hello everyone. Our project was MapMyAir. The goal of our project was to monitor the air quality around University of Buffalo's North Campus. For our system, we wanted it to be a mobile system and we wanted it to be able to function without the use of Wi-Fi. So, getting into our physical system now. Here is our microprocessor. It's a ThingSpeak 3.6. This is our LoRa radio. Use that just to connect to LoRa so we don't have to use Wi-Fi. This is our GPS sensor. This allows us to get the precise latitude, longitude, and altitude for any data points that we have. This right here is our air quality sensor. Pretty much what this does is it counts any air particles that are smaller than 2.5 microns. For the purposes of this project, we used it to count any particles that were greater than 1 micron per 0.1 liters, because that's what's harmful to humans. So, this is our Arduino script here, and essentially we just upload the code to the microprocessor. We'll get data from our sensors. So we'll get the GPS data, the air quality, and we'll be able to send all this data through LoRa. So I'll go ahead and upload the code now. So here I'm just uploading the code. This is our Arduino script that we used for the project. Essentially what this does is it sets up our LoRa transmission and it allows us to get the data from our sensors. So here I just opened up the serial monitor. And pretty much these are the steps that we use to connect to LoRa. So we have to do a system reset, make-it dev EUI. We set the app EUI, the app key, and the PWRIDX. We save all of that, reset the system, and then we attempt to join. Now, sometimes we get denied and sometimes it accepts us. So pretty much we just continuously run this block of code in a loop until we get accepted into the system. Unfortunately, right there we got accepted. So now this will start going through all of our other code. Now this code will run after we get a fix of 1. What that means is when our GPS sensor gets inaccurate latitude and longitude, it will then say, hey, I've got inaccurate latitude, longitude, and altitude, and then that'll allow us to go through and run the rest of our code, and it'll allow us to transmit. So right here, we're transmitting the latitude, and we decided to transmit our data 10 times just to ensure that our data would go through. We were having a little bit of trouble with data not coming through. And then here we've also got the longitude transmission going, and all of these are saying MAC-TX OK, which just means that the transmission went through successfully. And here the altitude transmission has started, and we'll let that go through. After our altitude transmits, the last thing we have left to transmit is our air quality. And as we can see here, the air quality starts to get transmitted. It's also important to note that if we run into some sort of transmission error, it will return MAC error, and we'll be able to resend that specific data point. And then afterwards, it'll just go through that loop again.
Gets sent from our hardware system over LoraWan. All of our packets get forwarded to a channel on ThingSpeak. The nice thing about ThingSpeak is all the data gets backed up as a JSON file, which can be accessed anywhere if you have the URL. So you could see kind of all of our data we've sent. We've set up our data to be sent as a hexadecimal, and we've set it up in a way that we can interpret the data and actually use it to plot all of our points. So once we've processed all our data, or once we've collected it, the processing gets done on the client application. So we pull all our data and plot each point based on the GPS and any qualities about that point onto the map. So if I click reload map here, it will get the most recent data from the internet and plot all the corresponding points. So within the application, we try to classify our data based on like the air quality in the area that we've collected. So for example, we just kind of like set arbitrary boundaries to classify like our data. So like say if the marker appears as green, that means like the air quality is very it's very breathable. There should be like no worries about like being outside. Though if it's a yellow or orange, it shows like kind of like a cautionary kind of point on the map. So maybe you should be more cautious being outside. The red shows that there's a lot of air particles in the air and you probably should be wearing a mask outside. So the last thing we've done with all of our data is we use our data to predict the air quality based on our classification at any point on the map. So you could just put in your latitude and longitude down here. So for example, I picked a point over here right by Lee Road next to the student union. So I'm curious, like without having like actual points collected, what the air quality is actually going to be. So based on putting that in, I hit predict and I get an output saying air has some pollution, take precaution when outside. So this can show you basically, like we can't collect every point on the map, but we could try to predict what the air quality is going to look like.